Request to all to please give your attendance in the chat box. Please give your attendance in the chat box. Also, kindly write which all topics do you guys prefer me to take it in the class, so that I can give priority to those topics. Okay, circles. Trigonometry. Two topics, triangular inequalities. See guys, in 2 hours class, I can only solve 3 to 4 topics. Half an hour I can give to each and every topic. If you want, I can increase the class to 2.5 hours. There is no problem with that. Okay, so I'm not starting. I'm. Do you guys want theorems also, or only questions? Because if I start taking theorems, it will take a lot of time for me to take theorems of circles. So it's better you refer to my previous classes where I have already revised theorems of circles. And in this class, let me only do questions. Okay, so this class I'll only take problems. Fine. So let me start with first problem. I'm first taking circles, then I take trigonometry, and then I go to triangular inequalities. The class may be a minimum of 2 hours. It can extend to 2.5 hours. So this is the question that you need to solve. Give me a moment. So suppose this is the circle and this is the diameter AB. So this one is diameter AB, and this is E, and these 2 points where this line AE and BE are intersecting the circle are CD. So this is C, this is D. I am drawing this CB, and this center is O. I am drawing this OD. So, and then I'm drawing this CO. So this angle angle COD is equal to 40 degrees. So what has been given to you? It has been given to you that AB is a diameter. The second thing which has been given to you that O is circle. Sorry, circle center. AC and BD are produced to meet at E, which can be seen over here, and angle COD is equal to 40 degrees. You find angle CD. Have you solved? Should I solve the question? So what I need to find over here is I need to find this angle. If I need to find this angle, you should understand that this angle is part of triangle BEC. So triangle angle CED can be written as, this angle can equivalently be written as angle CEB, because this point D falls on line BE. So there would not be any problem in renaming this particular angle as angle CEB. Now angle CEB is part of triangle BEC. So I need to find out other two angles of triangle um, uh, other two angles of triangle BCE. So you look at here, this angle ACB is equal to 90 degrees. Why? Because in a semicircle, diameter forms 90-degree angle. So the angle ACB is 90 degree. So on other side, this angle will also be 90 degree. So why? Because angle ACB plus angle ECB is equal to 180 degrees. This is already 90 degrees. So this ECB would also be equal to 90 degrees. So I got this angle as 90 degrees. Now let me try to find out the other angle. So I have already got this angle. Now I need to find out this angle. What would be this angle? So how to find this angle? Try to understand. This angle has been given as 40 degrees. So look at this angle DBC. Look, try to understand. Let me draw this here. What happens is, this is chord DB. Here is a line going like this C, and this line has not been drawn. I am reconstructing this line because this particular chord DB is making what angle? This is making angle 40 degrees. On the center. So this angle is 40 degrees on the center. So what would be this angle? This angle would be half of this angle 40 degrees. So angle DBC is equal to 20 degrees, which is equal to angle EBC. I have already told that D is equivalent to B. So this comes out to be 20 degrees. So you know that this is 90, this is 20. So total comes out to be 110. So this angle would be equal to 70 degrees. Okay, let me give you another question. Okay, let me mix and match questions. So now I'm giving you questions from, because there should not be the case that I'm doing one topic, I'm overemphasizing on one topic and leaving another topic. So okay, I'm taking questions from triangular inequalities. And the first question which I'm giving you is, prove that perimeter of a triangle, any triangle, perimeter of any triangle is greater than sum of its three medians. Solve it. I give you 2-3 minutes to solve it. Okay, 4 people have done it already. I'm waiting for others to answer. Can someone please send me the photocopy of photocopy from your book of trigonometry chapter? Now look at here. This is triangle ABC. So perimeter would be AB plus BC plus CA. This is median, so this is AD. So try to understand here. Sum of the two sides would be greater than the third side. So in triangle ADB, AB plus BD is greater than AD. Okay, thank you, Dhruti. I've got the sheets, so please. Thank you, Dhruti and Shraddha. I got the sheets. Now, try to understand. Now, in triangle ADC, AC plus DC is greater than AD. You add both of them, you get AB plus AC plus what is this? BD plus DC is equal to how much? That is BC is greater than 2AD. And likewise, you'll get it for all the medians, you'll get your result. Or what you can do is, okay, let me give that question only. Forget about this. Uh, Write down a question. Suppose O is any point in the interior of triangle ABC. Prove that OA plus OB plus OC is greater than half of AB plus BC plus CA. Okay, what of you have done? Let me give you a question from trigonometry. Find the value of solve the question I've written on the board. This question is easy. It's not about whether you have it in your syllabus or not. When you know that sine 90 minus theta is equal to cos theta, cos 90 minus theta is equal to sine theta, and tan 90 minus theta is equal to cot theta. Now tan theta multiplied by cot theta is equal to 1. So you look at here, tan 89 can be written as cot, sorry, tan 89 can be written as tan 90 minus 1. Tan 90 minus theta is cot theta, so this is cot 1. So this is tan 90, tan 89 is nothing but cot 1. And tan 1 and cot 1 getting multiplied will give me 1. Similarly, tan 2 and tan 88 will give me 1. Tan 3 and tan 87 will give me 1. In between, I'll have tan 45, which is already 1. So what do I get? I get the answer as 1. Okay, write another question. Prove that cos A minus sin A plus 1 divided by cos A plus sin A minus 1 is equal to cosec A Yes, got it. Okay, Ritu has done it. Okay, three people have written that they have done it. What about others? If they are not able to solve, let me know. I'll solve it. Ritu, Shraddha, and Anjana, sorry, Sanjana has done it. Anna has done it. Others, let me know. Okay, I'll solve it. So this question, one way to attempt this question is to, you take from here, this is cos A, you take minus from here, this is sine A minus 1, and this is cos A plus sine A minus 1. So you see here, this, if this is x and this complete thing is y, you get form x minus y and you get x plus y here. So now what I'll do, I'll multiply this with cos A plus sine A minus 1, and I'll multiply this with cos A plus sine. There are 2-3 methods to solve this question, so don't think that this is the only method. I'm taking the most obvious method by which most of you will start attempting it. So this will become nothing but a square minus b square. So this will become cos square A minus sine square, sorry, sine minus A, sine minus 1 whole square. Let me solve this numerator first and then I'll go to denominator. What is this? This is nothing but cos square A minus sine square A. This will become plus 1, so this will come out to be minus 1. And this will be minus 2 sine A, so that will become plus 2 sine A. And denominator would be cos square A plus sine square A plus 1 minus 2 sine A. So this will be nothing but, this is 1, so 1 plus 1, 2, 2 minus 2 sine A. So how to solve it? So you look at here, this is nothing but, let me solve here now. Cos square A can be written as 1 minus sine square A. So numerator is, now I'm writing 1 minus sine square A minus sine square A minus 1 plus 2 sine A divided by 2 minus 2 sine A. So this 1 and 1 gone, you get 2 sine A minus 2 sine square A divided by 2 minus 2 sine A. So what do you get? You take sine A common, you get 2 minus 2 sine A here and divided by 2 minus 2 sine A here. So I think I'm not getting what I have to get over here. So, because see, if I have to get, perhaps I have done some calculation mistake. I'm just checking for that. Taken a negative here, so this becomes plus sine A minus 1. Then I have multiplied it with, oh, I have taken wrong multiplication itself. So once again, let me solve it once again. This is cos A minus sine A minus 1, and this is cos A plus sine A minus 1. So I'll multiply this with cos A minus sine A minus 1 and this with cos A minus sine A minus 1. So what I get here is cos square A, this is plus sine A minus 1 whole square minus 2 cos A sine A minus 1. This is my numerator. In denominator, what I get is I get cos A square minus sine A minus 1 square. So what do I get now? I get here, let me just remove this. This is nothing but cos square A, and this is sine square A plus 1 minus 2 sine A, and this is nothing but 2 sine A cos A plus 2 cos A divided by, this is cos square A, and this comes out to be minus sine square A minus 1 and plus 2 sine A. So this is 1, so I'm writing it 1 plus 1, 2, 2 minus 2 sine A minus, let me write it as it is, 2 sine A cos A plus 2 cos A. And what I get here is I can convert it into 1 minus 2 sine square A, and this cos square is, and this is minus 1 plus 2 sine A. So this is nothing but what I have to prove here. Just let me check. Cosec A plus cot A. So look at here. Now I can prove this. So what I'll do is I'll take this and this gone. So I'll take 2 minus 2 sine A, and here I'll take sine A common. So this denominator will give me 2 minus 2 sine A here also. And what I'll do here is I'll write this as 2 cos A common and 1 minus 2 sine A, and this is nothing but 2 sine A. No, this is not 2, this is only 1 because I have taken common. 2 sine A, 1 minus sine A. So this and this is gone, and this is gone. This is 1 by sine A. 1 by sine A can be written as cosec A, and this is 2 gone. Cos A by sine A can be written as cot A. So this can be done like this. Now another way to solve this question is, I took time because I multiplied with wrong rationalizing factor. So another way to solve this question is, that somehow we utilize the thing cot square A, 1 plus cot square A is equal to cosec square A. Now how can you utilize this particular thing? So you need to convert it into cot and cosec. And how do you convert it into cot and cosec? So divide everything by sine A. So this gives me cos A by sine A is cot A minus 1 plus cosec A. And you divide this, you get cot A plus 1 minus cosec A. Now if you have this thing, so what you get over here is you can multiply this with, again I'm not doing the same rationalization again, you can multiply this with you can rationalize it by multiplying this with cot A minus 1 minus cosec A, and then you can utilize this formula 1 plus cot square A is equal to cosec square A. So by that method also you can solve this question. So whichever method you like, you can utilize that method. Now let me give you a question from Circle. You have to prove that the quadrilateral formed by angle bisectors of a cyclic quadrilateral is also cyclic. Let me know once you are done with the question. Have you done? Okay, three people have written that they have done. Okay, Varsha will solve it, don't worry. Now, try to understand the quadrilateral is formed by angular bisector of a cyclic quadrilateral. So first of all, I have a cyclic quadrilateral. So suppose I have a cyclic quadrilateral. Let me make a better circle for you. Okay, chalo. So I have a cyclic quadrilateral. Suppose I name the cyclic quadrilateral ABCD. So this is ABCD. And what I do is I have angular bisectors. Now angular bisectors are making a cyclic quadrilateral. So angular bisectors will make cyclic quadrilaterals something like this. So suppose this is P Q R S. I have to prove that P Q R S is a cyclic quadrilaterals. Now how to proceed it? So if I want to prove that PQRS are cyclic quadrilateral, I have to prove that this angle, which is angle APB, what is the property of cyclic quadrilateral? That opposite angles are supplementary to each other. So opposite angles will add and will give me 180 degrees. So APB plus CRD is equal to 180 degree. If I am able to prove this particular equation, I shall be able to prove that the cyclic quadrilateral PQRS is cyclic. So for that, what do I do? So I know that sum of the triangles is 180 degree. So what are the triangles I am taking? I am taking triangle APB. So in that angle APB plus angle PAB plus angle PBA is equal to 180 degree. Also, if I take triangle CRD, angle CRD plus angle RCD plus angle RDC is equal to 180 degree. Now try to understand that what is this angle PAB? Angle PAB is this angle. Now if this line PA is angular bisector, then this particular angle PA would be half of angle A. So I am writing here angle APB plus half of angle A, because PAB is half of angle A and PB and this PBA is half of angle B. So half of angle B is equal to 180 degree. Similarly, in this case, CRD plus half of angle C plus half of angle D would be equal to 180 degree. Now what to do in this case? So I'll add both of them. If I add both of them, see what happens. So this is equation 1 for me and this is equation 2 for me. I am adding equation 1 plus equation 2. What do I get? I get here angle APB plus angle CRD and half of angles A plus B plus C plus D, and that is equal to, on right hand side I have 180 plus 180, which is equal to 360 degree. Now any quadrilateral, angle A plus B plus C plus D would be equal to, you should understand, this would be equal to 360 degree. So half of 360 degree is 180 degree. So let me write APB plus angle CRD plus 180 degree is equal to 360 degree. So this goes on the other side. So angle APB plus angle CRD is equal to 360 degree minus 180 degree, which is equal to 180 degrees. That's how you prove this. I hope you understood this. Let me give you another question. If you have any question on this, you post it on the group. I'll try to solve it. Okay. Nobody is asking me any doubt, so I'm moving ahead. Let me give you another question. The question is from Circle itself. So look at the question. The question tells me that I'm writing this question. This is an NCERT question, and it's a very good question. It says that ABCD is a parallelogram. The circle through ABC intersects CD produced at E. Prove that AE is equal to ED. Sorry, AD. Once again, this is not ED, this is AD. Just solve it. Let me know once you are done. Okay, I'll solve it. Let's other solve it. Okay, Tana has done it. Okay, anyone else who is solving it? Otherwise, I'll solve it. 1 more minute. Okay, I'm solving it now. So, what needs to be done in this question? Try to understand ABCD is a parallelogram. So, let me draw ABCD. Now, CD is produced at E. So, this is point E. Now what happens? The circle through ABC intersects CD produced at E. So it means that there is a circle through ABC and which is meeting this E. So these 4 points A, B, C, E are on the circle. Just let me make this circle. There is some circle like this, and this E is on the circle. So let me join this line. This is A. So what happens? Why E is on circle? Already it has been given that A, B, C are on certain circle, and when CD is produced, it is meeting intersecting at E. So A, B, C is on circle. So hence A, B, C, E is a cyclic quadrilateral. So this much you could have done without without any difficulty. Now try to understand, if I have to prove AE is equal to AD and I know that ABC is a cyclic quadrilateral, then to prove that two sides are equal, I, I can only do it with the help of angles. And if I prove that this angle is equal to this angle, it means that if I am able to prove that angle AED is equal to angle ADE, my task would be completed. So let me prove this for you. Now, how do I prove this? So try to understand angle ADE, this angle, and on this side angle, plus angle ADC is equal to 180 degree. Now this angle ADC is equal to this angle because in parallelogram opposite angles are equal. So angle ADE plus angle ABC is equal to 180 degree. Now try to understand what can I write after this. So I can write that angle, one second, and there is one more angle I can write, which is angle ADE. Sorry, one second. I have to write something about, I have already written, try to understand what I'm trying to do. I have already taken this angle. Now you understand that in a cyclic quadrilateral, this angle and this angle add to 180 degree. So I can write that angle AED plus angle ABC is equal to 180 degree. So see here ABC and ABC is common, right hand side and right hand side is common. So I can say that angle AED is equal to angle ADE. And once I say that angle AED is equal to angle ADE, it means that these two sides, angle side AE is equal to side AD. What I have done in this question is, first I have taken this angle. So I have said that angle ADE plus angle ADC is equal to 180 degree, and I have replaced this ADC with ABC. And I already know that AED plus ABC is 180 degree because they are cyclic quadrilateral. So from there I am proving that angle AD is equal to angle AED. This is the case. So this is how you had to prove this question. This question was good. Unless you don't make good diagram in this question, you can't solve it. Let me move to triangular inequality in what is triangular inequality, which is here. Um, so let me solve few questions from triangular inequality. So I'm making a triangle for you. Just look at here. This is P, this is Q, this is R, this is T. So PQR is a triangle. S is any point. S is any point in interior. And I have already done the construction for you. Prove that SQ plus SR is lesser than PQ plus RT. Sorry, PR. Let me know once you are done. Okay, most of you are saying you have done this. So now I'm moving to a question on trigonometry. Let me find which question is good. And so the question is, prove that 1 plus tan square A divided by 1 plus cot square A is equal to 1 minus tan square A divided by 1 minus, sorry, this is not square here, 1 minus cot A square, and that is equal to tan square A. Just prove it. You done the question? Okay, three people have told that they have done. I'm waiting for others to do it. So Kana has also done it. Anyone else? Let me know. Let me know. Okay, if anyone wants me to do this, please type it in the chat box. Otherwise, I'll move to the next question. Because most of you have done this, there is no point doing it. If anyone wants me to do it, please let me know in the chat box. Shraddha, I'll send you the answer. Don't worry. I'll send you the answer. Don't worry. Okay, as no one is saying anything, I'm just going to next question. So I'm giving one more question of triangular inequality, and that is, okay, take this question only. Question says that PQRS is a quadrilateral. Diagonals are PR and QS, and these diagonals intersect at O. So you have to show that perimeter of quadrilateral is greater than PR plus QS. To solve this question, let me know once you are done with the question. Okay, two people have done it. Oh, more than two people have done it. A lot of people have done it. Okay, so let me move to the one question. This question I'm giving from circles. And The question is I'm writing the question. The bisector of angle B of an isosceles triangle ABC with AB is equal to AC meets the circumcircle of triangle ABC at point P and if AP and BC, I'll make the figure, AP and BC are reduced to meet at Q, prove that CQ is equal to CA. So suppose this is the circle, and in that circle I draw a line like this, and then I have another line. So this line is going like this, and this line is going like this, and I am joining these two points. This is something like this here, and this is something like this here. Now what happens is, let me name it for you. This is A, this is B, and this is C, this is P, this is Q. I've already told that AB is equal to BC, and you have to prove that CA is equal to CQ. Solve this question. Let me know once you are done with it. Once you are done, you let me know. I'm just waiting. Okay, Ritu, I'll solve it. I'm waiting for 2-3 more minutes so that others can reply. Okay, I'll solve it for you. As most of you are saying that I should solve it, I will solve it for you. Now, the first line that you read here is bisector of angle B. So, bisector of angle B is this line BP. So, the two angles, let me write angle AB, angle ABP is equal to angle PBQ. This Q can also be replaced with C because Q and C are on same line PB. Sorry, BQ. Now try to understand. I have to prove that CA is equal to CQ. It means that which triangle I have to take? I have to take triangle ACQ. If I have to take triangle ACQ, so in triangle ACQ, I have to prove that CQ, so I have to prove that this angle, I have to prove that angle CAQ and angle CQA is equal. If I am able to prove this, I will be able to prove that CQ is equal to CA. So what do I need to do in that particular case? Try to understand. Now, I know that exterior angle of any particular triangle is equal to sum of the two angles. It means that this angle ACB would be equal to the other two angles, and these two angles are the angles for which I am talking about, is equal to summation of these two angles CAQ plus CQA. Now what is angle? Now look at here. as AB is equal to AC, it's an isosceles triangle. So this and this is equal. It means that angle opposite to this will also be equal. So what I'm trying to say is that I want to take help of this angle to find out this angle. If I'm able to find out this angle or this angle, then some kind of relationship can be found out. So I know that angle ACB, if AB is equal to AC, so angle ACB is equal to angle ABC. And I also know that because line AP is bisector of angle B, I know that angle ABC can be written as 2 times angle PBC. PBC, PBQ, whatever you want to write. Angle PBC, I'm here only, I'm writing. So I'm writing this. So this angle ACB would be equal to 2 times angle PBC. So you look at here, I'm writing here that 2 times angle PBC is equal to angle CQA plus. Now try to understand one thing. Can I take help of this angle? Can this angle be written as some other angle? Tell me, guys. Can this angle, I'm giving you a hint, can this angle be written as, can angle CAQ be written as angle PBC? Just look, just try to understand why I'm writing this. If you are not understanding this, write it in the comment box. I'll explain it. Why I'm writing this? Because you try to understand, here is a chord which is invisible and most of you would have not drawn it. This chord will make same angle anywhere on the circle. So this chord is making PAC here and PBC here. Hence, angle CAP or CAQ will be equal to angle PBC, and that is why I am replacing this angle CAQ with angle PBC, because they are formed on the same chord. So I can write that angle PBC is equal to angle CQA. So this angle PBC is equal to angle CQA. So try to understand that angle PBC is equal to angle CQA and angle PBC is also equal to angle CAQ. So I can write that angle CAQ is equal to angle CQA, and if this is equal, then CQ is equal to CA. So somebody has posted me. I hope you understood this. Okay. So Shantanu, I'll pass on your message to Akhil. Which class you are in, just give me your details in the chat. I'll pass, give me your details, your personal details. I mean, not personal details in the sense which class do you attend, and I'll pass on your message to Akhil. Now let me give another question. Do you guys want me to continue with the class? I'll continue with the class, otherwise I'll wrap up. Okay, Shantanu, I'll pass on your message to Akhil. Um, Others, do you want me to give you more questions or you want me to wrap up the class? It depends on you. You're not saying anything. Okay, let me give you one more question then. Okay, so in this question, P is center. This is P and this is center. Now, this is X, this is Y, and this is Z. You have to prove that angle XPZ is equal to 2 times angle XZY plus angle YXZ. Shraddha, you try first. In 2 minutes, you say, sir, can you solve this? You try for 2 more minutes. This question is so easy. I don't want to solve it. Just look at the arcs properly and utilize the funda that uh, angle formed by any chord on the circle is half of the angle formed by it on the center. That's what you have to use it. I'm giving you a hint. This is very easy. Okay, those who are not getting it, try to understand. Look at chord XY. Chord XY is forming angle XPY on the center. So I'm writing here line by line. Chord XY forms angle XPY on center. And same chord XY, look at here, is forming angle XYZ on circle. So angle XPY would be equal to 2 times angle XZY. And similarly, if I take this chord, so chord YZ forms angle YPZ on center and angle, this angle YXZ on circle. So from here I can write YPZ is equal to 2 times angle YXZ. So let me add it. Angle XPY plus angle YPZ is equal to 2 times angle XZY plus angle YXZ. And this XPY plus YPZ, this is nothing but equal to angle XPZ. So this is what you had to prove. Okay, so I have done most of the done a lot of questions today. So I hope you understood the questions concepts clearly. Uh, if you feel like me doing more questions, you can write it in the chat box. Otherwise, I'll wrap up the session. Okay, so as no one is saying anything, I'm just wrapping up the session now. Um, so thank you so much for attending the class. And wish you all the best for your exam.